Hey, we have another integral today. This one's from the SwinBee 2023, problem 18. We have the integral of natural log x over x to the a dx, and we're given a condition that this a value is not equal to 1. So to get started with this, at first it'll look kind of intimidating with just having this a and the exponent, but actually I think we can do kind of normal methods on this. What I'm going to do first is I'm just going to do a u substitution to clean it up, substituting for the numerator. So what I'll do is I'll set u equal to natural log x. Then I can rearrange it and get a value for x, and we'll have x equal to e to the u. Then take a derivative, get a dx value, that's going to become just e to the u du. And then one thing I want to do before I substitute, we have x to the a here, and we have our value for x. So if I take this and raise both sides to the a power, on the left we have x to the a. On the right we're going to have e to the u to the a, but I can distribute in the a and write it as e to the au. And now I'll go ahead and substitute this. Our ln x is going to be u. Dx is all this. So we have e to the u du. And then we have our x to the a value. That's going to be e au. But because we have the same base here, wow, this is really not a very even the way I wrote that. We're pretty lopsided over here, but anyway, I can actually take this e with the same base and divide it into this one and rewrite. So what we'll have is e, and then we'll have this u in common. So I can write this as e to the 1 minus a times u du. But now what we have here, this doesn't look too bad. I think we can just use integration by parts on this. If I differentiate u, that's going to differentiate down to 0. So I'm going to create my table for the di method over here. And like I said, we're just differentiating u, integrating this thing. Just that exponent's going to be a little messy, but not too bad. So we'll start with a plus sign. If we differentiate u, we're going to get a 1. We'll do it one more time, and we differentiate this to 0. Then here, just treating this as a constant, when we integrate, we have e to the 1 minus a u, and we divide out the constant 1 minus a, and then we do it one more time, and we divide it out again, and we're going to have 1 minus a squared here. So this last row is going to be an integral, but because we have 0, that's going to zero out that integral, so we can just take our solution on the diagonals, or our solution in u. But when I do that, I think what I'll do, we have the e 1 minus a u in common, so I'll factor that out. And I think I'll also factor out the higher degree. We have like, this is a 1 degree and this is a 2. So I'm going to factor out 1 minus a squared. So doing it like that, we have this u on the first term, but I need to create another 1 minus a. Kind of think of it like creating a common denominator. If I multiply top and bottom here by 1 minus a, then we get the 1 minus a squared that I factored out, but we need to capture this. So we have this 1 minus a here, and then we've already factored out all this stuff, so this is just going to give me a minus 1 right here. And then now all we need to do is really back substitute in order to finish this off. But one thing I'm going to do is just try to set this up. Let me make a little space. For this term right here, I'm just going to rearrange it first because we have e to the 1a times u. I can rewrite this as e to the u to the 1 minus a, but then we have our value for e to the u when we back substitute. This right here is going to be x. So we'll go ahead and substitute that here using what we just did here. This is going to become x to the 1 minus a over 1 minus a squared. Then here I'll reorder it. I'll bring this 1 minus a in front. Our u is going to be ln x minus 1, add a plus c, and that's it. Okay, there it is. Really good problem from SwinBee 2023. Thanks everyone for watching today. Please like and subscribe. Have a good day.